So we have here the composition of functions, or the composition of the function f and g is denoted by, you have f and then there's a small circle g, and it's defined by the equation. We would say f of g of x, or we can also write it as, instead of the small circle between the f and g, we can write it as where the g of x is inside another set of parentheses, where you have a grouping symbol within a grouping symbol. It says here the domain of the composite function f, and how you say this, and I'll write it out, you're saying f of g of x. That's how you would read it. So if we had something such as, if you were given something like this, you would read it as g of h of x. Okay, so to know how to say it and be able to describe it, we would say, you can use the small circle. It looks like the word fog, but that's f of g, and then you say of x. Or we can write it without the small circle. You're saying f of g of x. Okay? The domain of the composite function f of g of x is a set of all x's such that x is in the domain of g, and number 2, g of x is in the domain of f. Okay? So, with me saying all of that, and also just said in another language here, a composite function, and we're going to do some examples. A composite of functions is one function acting upon another. So I want you to think of it as, think of it like putting one function inside of the other. Okay? So here again, we're saying f of g of x, which means that you plug the entire g of x function in for all x's in f of x. And to solve such a problem, we're going to do some examples. You work from the inside out. Okay? All right, so example 3, we're going to do 3 things here. Given f of x is equal to 3x minus 4, and g of x is equal to x squared minus 2x plus 6. We want to find each of the following. A, we want to find f of g of x. Then we want to find g of f of x. And then lastly, we're going to find g of f of 1. You have a number, the number 1. Okay. So, f of g of x is the same thing as saying, without the small circle here, we can write it with the grouping symbols. What you're saying here is you're going to you're working inside out. So what we have inside the parentheses, we have g of x. And what we're going to do is we're going to take this function g of x, and wherever we see x in for the function of f of x, we're going to plug in that expression. So what you're saying here is f of x is 3x plus 3x minus 4. Where we see x, we're going to plug in g of x. So that g of x, that function, you're saying 3 times x squared minus 2x plus 6, and then we simplify. Oh, I said 6. Where am I getting 4 from? Oh, wait. Okay, minus 6 minus 4. Thank you. All right, there we go. Distribute. So we have 3x squared minus 6x plus 18 minus 4, and then combine like terms. What's that, plus 14? Okay. All right, so working inward and out. Now, for B, we're going to do the opposite. G of f of x, where the function that we're going to work first is inside the f of x. Now our main function will be the g of x. So wherever we see x, the x is in the g of x with the x squared minus 2x minus 6. We're going to substitute this expression of 3x minus 4 into the g of x equation. Okay? So what you're saying here is, here's your g of x equation. And wherever we see x, we're going to plug in what we called f of x. So you're saying here, the quantity of 3 minus 4 squared minus 2 times 3x minus 4 plus 6. That 3x minus 4 squared, going back to multiplying polynomials, we're multiplying 3x minus 4 twice. We're going to FOIL. So we have here 9x squared minus 12x plus 16, adding our middle terms, 9x squared minus 24x plus 16. So that's just this part here, the 3x minus 4 squared. Then we're going to distribute the negative 2 to the 3x and to the minus 4. So we have minus 6x plus 8, and then bring down the 6. Then any like terms that we need to combine, we will do so. And I see some. We have the minus 24x and the minus 6x. So we have here 9x squared minus 30x. Then we're going to add 16 to 8 and 6, and that gives us, is that 30? Okay. So that is g of f of x. Now, part C. We're finding g of f of 1. That's what it's saying. Now, there's no need for us to go back and try to take, plug in 1 in. You can do this. You can go in and take the working inward and out, f of 1. What this is saying is that you can substitute 1 in for x into the function of f equation. Get a solution. And then from that solution, plug into the g of x equation. There's really no need to do that. Here's why. Because we found for part B, we found g of f of x. So we know what that is equal to. We know what it's equal to. So all you have to do, since we know that g of f of x is equal to 9x squared minus 30x plus 30, all we have to do is go in and substitute 1 in for the x here. So 9 times 1 squared minus 30 times 1 plus 30. We have 9 times 1 minus 30 times 1 again plus 30. 9 minus 30 plus 30, and we're going to end up with 9. There we go.